Hey, Chem 20s. I almost just recorded an entire lesson without the microphone turned on. It's a good thing I checked. So, welcome back. Last class we talked about gravimetric stoichiometry. Gravimetric stoichiometry was all about masses. So typically you're given a mass of one substance, you have to figure out the moles of that one substance. Then you use your mole ratio to figure out the moles of another substance. And then you use your molar mass again to figure out the mass of another substance. So molar mass gets us between mass and moles, and then the mole ratio gets us from moles of one substance to moles of another. You're going to see something very, very, very similar today as we go through solution stoichiometry, except we're going to be dealing with volumes and concentrations. Volumes and concentrations. So let's jump right in. Let's have a look. I'm on page 13 here. I know that I skipped over a lab exercise on page 12. If you want to check that one out, that is absolutely 100% okay. We're going to call that extension or bonus material for the time being. But the one thing that I do want to look at from that lab is just the idea of percent yield calculations. So that's right here. So typically what we have in a lab situation, in a gravimetric stoichiometry lab situation, is you do a chemical reaction in a beaker. So you have one substance in your beaker and you might pour another substance into that beaker, and as you pour it in, a precipitate forms on the bottom. So double replacement reaction is very, very common for that one. And you might precipitate something out. Oftentimes what we look at here is we then filter. So this is representing it looks like an old TV set, but we filter out. So here's filter paper inside of a funnel. We pour all of that into the filter paper, and then the liquid drips down and we filter the precipitate out. Cool, that's no problem. And then what we end up with is a wet piece of filter paper with some precipitate. So there's the powdered precipitate on it. Now, if you want to figure out how well you did that chemical reaction, you can figure out your percentage yield. So how much you actually got, the yield that you actually got out of your chemical reaction versus your predicted yield. So your predicted yield is the part that comes from your stoichiometric calculations. It's how much you should have got versus how much you did get. Now, I forgot to mention one thing. You probably want to get the mass of the naked filter paper beforehand, because when it comes time to get the mass of your precipitate, you typically take your filter paper with the precipitate on it and you get your mass for that one. It has to be dried, by the way. You don't want the mass of the water. And you subtract the mass of your naked precipitate, or naked filter paper. That's not a real term. Please don't go into Chem 30 and start calling it a naked precipitate. Your teacher will look at you like you're a weirdo. But your empty I'm losing track here now. Your empty filter paper, and that'll give you just the mass of your precipitate. Right? So filter paper with precipitate minus the mass of the filter paper itself gives you the mass of the precipitate. Then you can go in and then you can actually look at this formula. So that's going to give you your mass actual, and you can divide that by your predicted yield. So your predicted yield is from your stoichiometric calculation, and you multiply it by 100. So just like on a test, if you got 50 out of 60 questions on a test, your actual questions were 50. Your predicted, so what you could have potentially got, would it be 60? You do 50 divided by 60 and then times 100 to get in percentage form. Nice. So just wanted to point that out and make sure that you understood that, because you will run into that in Chem 30 a little bit. So we're going to skip over lab exercise 7b. Again, you can 100% check that out if you want to. It is it's bonus material for us right here and right now in this COVID-19 situation that we're in. And we want to jump into solution stoichiometry on page 14. So this is just like gravimetric stoichiometry. It's kind of the same thing over and over and over again, right? We start with a balanced chemical reaction. We're going to be given enough information to figure out the moles of something. We use our mole ratio to figure out the moles of something else, and then we solve the problem either again using concentrations or potentially using Well, masses and molar masses. So same sort of idea. Find the amount of something, use that to find the amount of something else, and then find whatever the question is looking for. Cool, so that might not make a ton of sense what I wrote right there. Let's just jump right in and have a look. So first example, silver nitrate and sodium chromate solutions react as follows, and it gives us our balanced chemical reaction, which is fantastic. Part A, how many moles of silver chromate form when 0.2 moles of silver nitrate react? So this actually isn't even solution stoichiometry yet. This is exactly the same thing that we had before. So let's see, how many moles of silver chromate form? So that's this. We're looking for the number of moles of the silver chromate, and we've got 0.2 moles of silver nitrate. That's this, 0.2 moles reactant. So my moles of Ag2CrO4, this is where it gets kind of annoying, but don't be lazy writing that out every time. And having those little tags, like telling me which, and telling yourself which amount, which mass, all of those pieces, that's just so helpful as we go through. So let's start with the thing that we know. We know that we've got 0.2 moles of the silver Ag nitrate, AgNO3. We know that we've got 0.2 moles. You can, again, you can put that over 1 if you want to, if you want a distinct top and bottom. We want to multiply that by a conversion factor, so a thing with a distinct top and bottom, to figure out the moles of silver chromate. Well, this is just a one-stepper here. So silver chromate, I'm going to put moles of silver nitrate on the bottom, AgNO3. Therefore, the moles of AgNO3 will cancel with the moles of AgNO3, and I end up with my silver chromate, AgCrO4, Ag2CrO4. Nice. And now I just look at my molar ratio. Same thing that we did the other day. My mole ratio, let's see, in front of the silver nitrate, I've got a 2, and in front of the silver chromate, there it is, I've got a 1. So essentially, I'm going to take my 0.2, I'm going to multiply by 1, and divide it by 2, so that's 0.1 moles per liter. You know what? I can do better. I can absolutely do better. We need some sig digs here. 0.10, it turned black all of a sudden. 0.100 moles per liter. I'm not entirely sure how or why it did that, but that's okay. Cool, so literally nothing different. Okay, let's check out part B. This is where it's ever so slightly different. I'm going to clean up the thing up top here, my original chemical reaction equation, because we're going to use that again. So how many moles of sodium nitrate, that's the point of the question, form when 500 milliliters of the 0.3 mole per liter sodium chromate solution react with silver nitrate? Okay, let's summarize this. Again, I'm going to summarize this. I'm going to work in black now because that's the color that I'm in. And I'm going to summarize this up here underneath my chemical reaction. You may or may not want to do this. I have an easy time erasing on the smartboard. Piece of paper, maybe a little less so. So let's see. We've got 500 milliliters. I might change that to liters, so 0.5 liters. And that's talking about my sodium chromate. So 0.5 liters and 0.3 moles per liter. Excellent. Just right off the bat, looking at that, I can go through and I can say, oh, well, if I have the volume and I have the concentration, I should be able to figure out the number of moles of that sodium chromate. Let's see. Part B says, how many moles of sodium nitrate, that's this one, are formed? So the moles of that is my question mark. Cool. So let's go through and let's start to figure it out. So my moles of NaNO3, that's going to be equal to, and always start with the thing that you know information about. So that is my sodium chromate. So again, it's going to be 0.5 liters of sodium chromate, Na2CrO4. Again, you can put that over a 1 if you want to. Now I need to go ahead and get rid of the liters and end up with moles. Cool, okay, so that means liters has to go on the bottom. And that's going to be liters of Na2CrO4. This is important not to get lazy with that. We see that that whole piece cancels with that whole piece, and I want moles of Na2CrO4 on the top. Now I just got to look, it's 0.3 moles per liter, so the 0.3 goes with the liters, or sorry, with the moles, and the 1 goes with the liter. So 0.3 moles for every 1 liter. Now if we were to stop right here, we would have the moles of sodium chromate. We don't really want to have the moles of sodium chromate. We're actually looking for the moles of sodium nitrate, so I need to use my mole ratio to get the moles of sodium nitrate. Cool, okay. So I want to cancel out moles of Na2CrO4. So it's on the top here. It's going to cancel with the one on the bottom over there. I'm going to end up with moles of sodium nitrate, NaNO3. Cool, then I just go back and look at my mole ratio. So NaNO3 has a 2 in front of it. That's no problem. And Na2CrO3, or my sodium chromate, has a 1 in front of it. Well, technically has nothing in front of it. But if there's nothing in front of it, we know that that just means that there's a 1. So let's get out our trusted calculators and let's do 0.5 times 0.3 divided by 1. I don't need to divide by 1, but I do need to multiply it by 2, and that works out to be 0.300, I think 3 sigdigs moles of our sodium nitrate. Cool, so that's not so bad. Not so bad at all. Again, it's just kind of canceling out units to get you where you need to go. Start with the thing that you know information about and work your way towards the thing that you're looking for. Cool, let's, I might choose a different color here just for the last one, clean up my original equation. You'll notice with this that I always like to have my original, let's do this color. I always like this color. Always like to have my original equation and then just sort of summarize the information underneath my original reaction equation. That really helps me out. So let's go ahead and do that. Part C, put that right there. So how many grams, that's our question mark, how many grams, it's mass. Okay, how many grams of precipitate will form if 200 milliliters of 0.5 mole per liter silver nitrate react with sodium chromate? Oh boy, okay, that's a lot. So I've got 200 milliliters of 0.5 mole per liter silver nitrate. So silver nitrate, that's right here. I've got 0.2 liters, or 200 milliliters. And I've got a concentration of, let's see, it was 0.5 moles per liter. So that's a lot easier to deal with than out of the sentence down below. So how many grams of precipitate will form? How many grams of precipitate will form? Well, what's the precipitate? The precipitate is the thing that comes out as a solid. So how many grams? Well, that's the mass. That's what I'm looking for right there. That's the mass. Now I know if I ever want to go from mass to moles or moles to mass, I need my molar mass. So I better get my calculator out, and I might as well go through and check out that molar mass right now. So I actually need to look at my data book because I have no idea about chromium. So let's see, that's 2 silvers, right? That's right, yeah, precipitate, 2 silvers. So 2 times 107, and you should be doing this as well, making sure that you know how to do this and you're getting the same number. So 2 times 107.87, that's my 2 silvers, plus my chromate. Oh boy, we got to find chromate here, chromium. It's number 24. So check out number 24 on our periodic table. And let's see, we've only got one of those, so plus 52. Then we're going to add to that 4 oxygens, so 4 times 16. It's going to be a big one, I think. 331.74. So my molar mass, 331.74 grams for every 1 mole. Nice. Okay. Now I think we're ready to jump in and start trying to figure that mass. So I'm going to start way over on the left-hand side. My mass of precipitate, and let's see, the precipitate was silver chromate, Ag2CrO4, is going to be equal to, okay, now I got to go back. There should be enough information that I can find the moles of something. I think it's actually going to work out to be my silver nitrate. So I'm going to start with my 0.2 liters, 0.2 liters of silver nitrate, NaNO3. Again, you can put that over 1 if you want to. Now I'm looking for the moles, right? So I need, in my conversion factor, I need to get rid of liters of NaNO3, and I want to end up with moles of NaNO3. Cool. A little bit tedious, but we can absolutely do that. And now I know that it is 0.5 moles for every 1 liter. So the 0.5 goes with the moles, the 1 goes with the liters. We see liters of NaNO3 canceling with liters of NaNO3. Perfect. Now I've got my moles of NaNO3. Nice. Now I want to use my mole ratio because I don't really want the NaNO3. I want the, what is it there? The silver chromate. So let's see. I'm going to cancel out moles of NaNO3. It was on the top. Now I'm putting it on the bottom. I want to end up with moles of my silver chromate. So this one goes on the top. AgCrO4, Ag2, sorry. 0.04. Then I just have to go back up and look at my mole ratio. Let's check it out here. So there is a 2 in front of the silver nitrate and a 1 in front of my silver chromate. Oh, I think I screwed something up there. It's not sodium. Dang it. It is silver. Well, whatever. I'll still put a 2 and a 1, and I'll have to go back and change it. My apologies there, folks. My apologies. So everywhere you see sodium, see, there's a sodium there, sodium there. Oh, it's everywhere. And a sodium there, we'll just put a silver just to make it nice and neat. So silver, silver, and finally silver. And this one can actually cancel out. Perfect. Okay, so it was a bit annoying, but we got it. We got our mole ratio. Now we've got the moles of silver chromate. Now, if I wanted to go from moles to mass, well, that's where the molar mass comes in. I'm not even going to worry about the numbers for right now. I'm just going to worry about canceling out my units. So my moles of silver chromate have to go in the bottom so that moles cancel with moles. Then I want my grams of silver chromate, AgCrO4, to go on the top, because what are we looking for? We're looking for how many grams of precipitate. Well, that's how many grams of AgCrO4. So let's have a look here. Back up. We've got 331.74 grams per mole. So that's 331.74, just barely enough space, grams for every 1 mole. And look at the only thing we've got left. We've got grams of silver chromate, which is grams of our precipitate. That is wonderful. All we have to do is plug that into our calculator now, starting way over on this side. So 0.2 times 0.5, don't really need to divide by 1, times 1, I don't really need to times by 1, divided by 2, just anything on the top we multiply, anything on the bottom we divide. And then finally, times way over there on the right-hand side, 331.74. And again, divided by 1, but that doesn't really matter. So this works out to be 16.587, which, with proper rounding, is 16.6 grams. Perfect. Okay, this is solution Stoich. All you're going to be doing from here until, let me just find the page number here, from here until page 18, it's realistically the same thing over and over and over again. Same as one of these 3, A, B, or C. So you're given some information about one thing. You can find the moles, or you're given the moles about one thing. Use that and the mole ratio to figure out the moles of something else, and then use either, say, the volume, use the molar mass, use whatever to find your last thing. I know that doesn't make a ton of sense, but let's recap it right here. I'll use a different color to recap. Actually, let's go back and let's do it this way. Different color to recap. There we go. So we found the moles. That's what we did here. Then we used our mole ratio to find the moles of something else. Then in this case, we used over here, once we found the moles of something else, we used the molar mass to figure out the mass. Same thing over and over and over again. For sake of time here, I'm probably going to leave it there. So you've got example 2, you've got example 3. The solutions are on the internet for that one. Remember, the page numbers are a little bit messed up. So solutions for the solution Stoich start on page 16 of the thing on the internet, whereas here I believe we are on page 14 still. So they're shifted just by a little bit, but you can find the space pretty easily. And then again, lots and lots and lots of practice. Here's what I really want you to do with this. Please make sure that you practice until you feel comfortable. Practice until you feel comfortable. There's also a lab exercise that's bonus material if you really wanted to, but you can check that out. But that is essentially it for solution stoichiometry. So practice, practice, practice. This is such an important skill for Chem 30. This is probably one of the most important skills for Chem 30 is how to do this stoichiometry stuff. And like I say, it's kind of the same thing over and over and over again. So anyways, that's it for today. Please contact me if you need any help with anything or if you're struggling, and I'll definitely help you out. Anyways, bye for now, Chem 30s, or Chem 20s, Chem 20s. Bye for now.